Hello and welcome back. In this video we're going to find an equation of the hyperbola with center at the origin, one focus at 3, 0, and one vertex at -2, 0. Then we'll graph the equation. Let's make a graph of what we have been given so far. We have a center at 0, 0, a focus at 3, 0, and a vertex at -2, 0. Since the y-coordinate of our center, focus, and vertex is 0, we know that the transverse axis is the x-axis. Since one focus is at 3, 0, C is equal to 3. Since one vertex is at -a, 0, A equals 2. We can use the formula b squared equals c squared minus a squared to find the value of b. Substituting values for c and a, we have b squared equals 9 minus 4, so b squared equals 5, or b equals plus or minus the square root of 5. Our hyperbolic equation takes the form of x squared over a squared minus y squared over b squared equals 1. Substituting our known values for a squared and b squared, we get x squared over 4 minus y squared over 5 equals 1. Let's plot the points that we have so far. We have our center at 0, 0, vertices at 2, 0, and -2, 0, and foci at 3, 0, and -3, 0. We need to find additional points above and below the foci, so we'll let x equal plus or minus 3 and plug that into the equation of the hyperbola. Then we'll solve for y. Let's plot our known points. Center at 0, 0, vertices at plus or minus 2, 0, foci at plus or minus 3, 0. But we're not quite ready to graph our hyperbola. We still need to find additional points. What we'll do is we'll find points above and below the foci by substituting plus or minus 3 into our equation, x squared over 4 minus y squared over 5 equals 1. That gives us plus or minus 3 squared over 4 minus y squared over 5 equals 1. Or 9/4 minus y squared over 5 equals 1. Next, we'll solve for y. I won't show the arithmetic here. You might want to pause the video for a moment to work it out. But once you do work it out, you should get y squared equals 25 over 4, or y equals plus or minus 5/2. This means that our additional points are at 3 5/2, 3 -5/2, -3 5/2, and -3 5/2. We'll connect our vertices with these additional points to create our hyperbola. So now we have found an equation of the hyperbola, created its graph, and this concludes our example. See you next time.